Thank you for joining me today as we discuss an urgent issue facing humanity, global hunger and food insecurity, and our novel solution to combat it. The United Nations reports that 10% of the global population faces hunger, with 1 in 3, a total of 2.3 billion people worldwide, experiencing moderate to severe food insecurity. The Woodwell Climate Research Centre predicts a significant rise in global crop failure rates, foreseeing a 4.5-fold increase by 2030. Decreased food security due to changes in climate will disproportionately affect countries in the developing world, with many regions already facing collapse of subsistence agriculture and UN famine relief mechanisms currently underperforming. Rice, Oryza sativa, a primary food source for half the world's population, is particularly sensitive to rising global temperatures. Excess of 33 degrees Celsius day and 27 degrees Celsius night compromise rice cultivation through decline in photosynthesis and metabolic activity, ultimately producing smaller yields and potential crop losses or failure. Addressing imminent food crises necessitates proactive strategies to detect early signs of food supply disruption due to climate-driven rice crop failures. To determine indicators for imminent crop failure in Oryza sativa rice crops, we propose the use of glasshouses at Macquarie University Plant Growth Facility. This site contains 16 glasshouses ranging in size from 27 to 55 metres squared and 14 growth cabinets. These facilities are fitted with red-blue LED lighting systems, water and temperature control systems, and CO2 and humidity control systems which allow for complete control over key factors of plant growth. Our goal is to monitor rice crops placed under different adverse conditions to determine the indicators for imminent crop failure. Rice has a 6-month growth cycle, approximately 180 days, which means this study will begin early in the year, January or early February, to complete the growth period by July or early August. The next stage of our plan will be to analyse data collected from the plant growth facility to determine indicators of imminent crop failure. To collect data on the health status of rice crops, we will use the industry standard metric for measuring crop health, the Normalised Difference Vegetation Index, or NDVI for short. NDVI quantifies vegetation health using near-infrared, which is reflected by vegetation, and red light, which is absorbed by vegetation. If we observe the way this NDVI changes when rice is undergoing failure, we can employ model fitting techniques to detect this imminent failure before conventional systems such as machine learning and satellite observations can detect it, buying more vital time for communities to prepare. These algorithms can then be installed on existing consumer-grade drones, such as the P4 multispectral agricultural drone developed by DJI for the purposes of crop health monitoring. These drones can then be fitted using the open source detection algorithms by industry partners and NGOs alike to survey all types of rice paddies, from small-scale subsistence farms to agricultural powerhouses. Now, as we delve into the potential for drone-based agricultural monitoring, let's turn our focus to the key factors ensuring its effectiveness and sustainability for economic, environmental, and social factors. For economic sustainability, high equipment costs can hinder adoption, particularly in underdeveloped regions. Cost-saving options such as partnership with drone manufacturers and open-source software are being explored. Environmental sustainability. Drone monitoring reduces pesticides and fertilizer use, enhancing irrigation efficiency and lowering agriculture's environmental impact. Focus on energy-efficient drones and eco-friendly manufacturing techniques is imperative. And social sustainability. Drone-based monitoring boosts food security and poverty reduction. Engagement with local communities is essential to ensure broad acceptance and benefits. Additionally, fostering collaboration and data sharing among stakeholders is vital to enhance data utilisation by farmers and relief organisations. Comprehensive involvement of all relevant parties is essential in drone-based crop monitoring projects. Thank you.